So good morning. I'm going to talk about legacy code and how I deal with legacy code. I'm going to explain a bit how it is how our natural fears stop us from having this more, let's say, efficient way with dealing with legacy code. For me, as I saw with teams, especially in big projects, teams feel something like this. Legacy code is like an area where you don't want to touch anything. It is a very dangerous place. By the way, this is me. I do a lot of training and coaching, but also I write software. I learned a lot of these things through my journeys through the communities in Europe, but also from my customers. So these are mainly my experiences. It's not something I read in a book. It could add up to other books that were written on the subject. So I'm going to talk about current situation when you're afraid of legacy code, and the better situation where you could, in fact, deliver at least on time when you want to change legacy code. And I have this scenario that often happens, but for this scenario to work, you need to have a reason. Often people just change the code just because they want to. And this is wrong. The only three reasons I found to change a legacy system is if you want to fix a bug, if you want to add a feature, or if you understand that you have a core part of the system which, if it will fail, it will generate you bankruptcy or extreme loss of money. And that's the core part of the system. So you need to have automated tests for the system core. These are the only reasons why I found it's good to change legacy code. Why not to change legacy code? There are many reasons, but I found these three. I don't like it. It looks ugly. And then the programmers stay for some weeks or months just to make it nicer. But what are you investing in? This is not something you should do as a programmer. And as an architect, as a team leader, you should know that the team is doing this. And this is also very dangerous because it could introduce defects. It could change APIs just because you want to make it nicer. So you shouldn't do that. Or something like that, I want to update the newest framework. Why? I know that programmers have this feeling, well, we need the shiny new thing. But in a system that works, you don't need to update anything. It just works. I don't know if you know, but there are many of the banks we use now have COBOL systems working. No one touches them because they work. In 20 or 25 years or 30 years, they were developed in such a way that they can be used as they are. No one needs to change them anymore because they are this core system that interacts to something else. So they have some wrappers, and that's it. It's COBOL. Okay, it may be ugly, but it doesn't have bugs or not a lot of bugs. And it has been working for 25 years. So why should I update to something new, to enterprise Java? Or I don't need that. For the business, it would be a mistake. And as a programmer, I need to understand that this is not something to do. So let me tell you about this story. You have this manager who is very serious and says, I want you to add some features to this old project. And this is just pure hypothetical. It never happened. And then they tell you you need to do it in this time. Don't ask you for estimates. Don't ask you for anything else. Just do it in 1 week, 2 weeks. But that generates a normal sense of fear, right? So what you do is you're afraid to change it. And you look at this task with this sense of fear, and you don't really want to do it. And you look after that at the code base, and you understand that you cannot do it. And you have pressure. Pressure from the time. You make mistakes because of that. And the time feels way too short. Then you just go to your manager and say, no, I cannot do it. It's too short. It's too complicated. And of course, it generates discussions and not such a nice atmosphere at the office. But of course, the manager says, of course, we can do it because we're good and we know our systems and we have very good programmers and the requirements are very clear. But in fact, probably none of these things are 100% true. So usually it takes, in the best case, double the time you said, or you expected. Not the manager, but the time you expected. So if the manager would say it takes 2 weeks, you say it takes 4 weeks, probably it will take around 2 months. This is from my experience. It takes a lot of time because understanding legacy code in such a way is very difficult. And then if you want to test it and retest it and see if you introduce defects, that takes a lot of time again. And then you solve the defects and other defects appear. So you have this chain of things. So you lose money, your customer loses money, your customer starts having these thoughts that you're not that efficient, competitive. So it's not a good situation. And of course, everyone is stressed. And again, the atmosphere in the teams will generate this lack of efficiency. Now, a bit of a better situation is if someone signs this contract to add some features to add to a project. But before having, I'd say, an estimate, what you do, you look a bit at the code. So the idea is not only to look at the code and read it. It's not enough. If you read the code, you don't understand it. That is the truth. We all say we are programmers, we're smart, we understand 5 languages, and we know all this enterprise system. We've worked on it for 10 years, but we don't really understand the intricacies of legacy code. This is why we need to write characterization tests. These are the kind of tests that you write from outside the system to characterize the features of the system. But the difficult part in writing characterization tests is to write them on this thin layer of the code where you need to fix the bug, add the feature, or test the system core. Not a lot. And it might feel very small, very thin, but you can almost always find something thinner, something that you can test faster. And these are kind of end-to-end tests. In the beginning, you start from the outside, and then you start hitting errors, exceptions, databases, web services, file systems, whatever. So you hit the external world. And when you hit that, you understand that you need to find some way of stealing the outputs from this because you cannot really test with external third-party web services, right? So here, you need to have a lot of imagination on how to get these outputs without changing the code. This is where the most difficult part of working with legacy code is. Because you might, I don't know, create an interface, create a class and push it in somehow through configuration. Or push somehow the file system that you'll steal the streams of the outputs without really writing to the file stream. Or things like that, that require a lot of imagination and knowledge about the framework. But you don't need to change at all the code. That's what you do with characterization tests. In a way, you poke the system from outside, and you want to see, OK, until here, what's going on? And you make the test work, in a way. But each situation is different. This is why you need imagination. And you need sometimes a team. You need to pair up with someone to be fast enough. But these tests also will start being end-to-end tests at some time, because you own some systems. So you could, I don't know, create end-to-end tests with in-memory database. So you just take the structure of the database, you put it in memory, and you create these end-to-end tests. So it's easier to do these things with things you own on the outside world. But with things you don't own, it's difficult, especially if you don't have an integration layer. Also, you need to understand these external dependencies, how they work. Because just having an API is not enough. And you need to write these tests against the external systems. So the end-to-end tests are from the outside, from the GUI, from beneath the GUI, from the API, towards external parties. Like, for me, external parties, a database, file system, anything that's, let's say, statical, and you cannot really use unit tests on that. And after that, you start understanding the system. This is what means that you characterize it. You understand what it really does. And I often have these moments, oh, this is what it really does, but the method said something totally different. Because it's legacy code. This is how legacy code is. And sometimes these end-to-end tests can be split into integration tests, so tests that will hit from the inside. So you have the system, and you hit it from the inside of the system to the outside, like writing tests towards the file system. Say, look, I write this file. This is how it works. Maybe I use a library for, I don't know, zip. And I want to write tests towards it, to integrate with it, to see how it works. And if I isolate myself from this world in a way, after I have this end-to-end test, I can start changing the code. And I can start adding integration layers. And this integration layer will help me have this more like a component test, which will be extremely fast compared to the end-to-end test. So I have faster feedback. And I increase my level of confidence of changing the code because I have this safety net at the beginning. So this is why the end-to-end test could be split into integration tests and unit tests. So integration tests that test the outside world and unit tests that are inside. And after you have this second safety net of component tests and integration tests, you can start refactoring a bit with care. And you can start adding unit tests. But again, you should add them only on the places where you know that you need to fix the bug. You need to know that this is where I need to add the feature. This is where I need to write this test to make it work, to test the core part of the system. Not here, just because I don't like the code and I want to change it. you need to focus where you need to add the feature. And the characterization tests before help you understand where you need to do this. So you learn the system, in fact. Now, what you need to do here is to refactor a lot. And I use the IDE extremely, well, usually I do these things in statical languages. And in statical languages, you have very powerful IDEs that help you do fast refactorings, automatic refactorings. So you should use your IDE as fast as you can, because you need to refactor a lot. And you don't need just to write things, because if you write things, while you write on your keyboard, you could introduce mistakes. Sometimes IDEs have bugs on refactorings, especially on things like move method, inline, not on rename, but sometimes on rename as well. On extract method. So be careful how you use them, because the IDEs are not 100% safe. So just saying, I want to use safe refactorings, and I just use the IDE, that's not correct. You need to understand also what the IDE does inside. And maybe if you want to do this, to learn about this, read the refactoring book by Martin Fowler. And you'll understand the steps for each refactoring. And in dynamical languages, I use these refactorings by hand. So you do safe refactorings in small steps that don't break anything. And you always have a feedback loop of, I don't know, tests or something. You don't have necessarily a compiler, but you need to have a feedback in a way. So you use refactorings to improve the design. Now, you are able to add the feature. You made room for the feature. That's the idea. By refactoring, you made room to plug in this feature. Because, of course, you need to know how you add this feature, so the refactorings should be as small as possible, so you'd have this integration layer with the new thing, wherever it's needed. And usually when I add this feature, it is fully automated. So I usually write TDD or something like that for the new feature, and that has a lot of tests. And then the testers will have this final exploratory testing part or manual testing to see if the system works well for the happy paths usually, but not necessarily. It depends on what you want to do. So you have a better situation. The team could deliver on time because you had feedback from the system. You learned a bit the system upfront, and you gave a, let's say, more accurate estimation based on the things you learned from the system. After you write the characterization test in the beginning, you start understanding the system. So if you do that for a couple of days, you start understanding how complicated this is or how simple this is. So you can deliver on time. It's not necessarily always, but if you know the system and if you work with confidence and you have the right tools and you know the right tools, then you'll be able to do this. So the most important thing is that your customer starts trusting you even more. Your customer doesn't want to add this feature now. They want to have a trustful partner to deliver value with you. So it's a very big mistake to say, if we won't deliver this fast, they will fire us. This happens so seldom, so I don't think we should take it into consideration. So my problem is this, that legacy code is fear. And our unknowns are making us afraid. There are different types of unknowns. There are unknowns of the system, of the framework, unknowns of our tools. Maybe you don't know how to use the IDE, you don't know how the language works, you don't know how to write unit tests, you don't know how to integrate with some big systems. So usually, if the team is afraid to do something, they don't know something. But they don't want to say it like that, because we're programmers and we're proud. So the next step is automating tests that minimizes the mistakes we do. We might have introduced defects, but not that many. And also, we can increase the confidence of the team that we're going on a good path. We can show these tests to the customer. And they have feedback. Look, we added this feature. Look at these acceptance tests. So we have confidence inside the team, inside the company, and outside the company as well. So it sounds very nice. But how to do this if you have a team who is afraid about working with legacy code? So the things I do is I start talking with the team very honestly. And I ask them what are the things they do not know. And things like that appear. Domain knowledge, programming languages. I don't know this part of Java that well. Unit testing. Yes, we do unit testing. How many tests do you write per week? 2. I don't know. Maybe it means that you need to learn a bit more before tackling a legacy code system. Acceptance testing. How well are you able to use these tools? And frameworks and so on. So you start understanding, first of all, the levels of knowledge, of technical knowledge, on a very sincere level. Don't think that they know more. Don't tell them you know everything. You're my good programmers, because you will have false answers. And then what I do is I start with a smaller problem, something like a play problem that you can understand fast enough. And we learn how to write characterization tests for this problem. Sometimes in pairs, sometimes we use coding dojos or mob programming to practice together. So do you know coding dojos? Yeah? So more people work together on a projector, and they switch every 5 to 7 minutes, and everyone gets to write code. We usually do this in groups of like 7, 8 people, not more. And it takes like 1.5 hours, 2 hours. Mob programming is a bit the same, but the person who's writing code is just listening for what the group is saying. So you have 7, 8 people behind you, and they were saying, we should do this, we should do this. And so the person writing code is just the hands of the mob. And often you deliver things so fast compared to just 8 people doing things by their own, because you have a lot of brains doing that, and they focus on this. And it takes around 1 hour, 2 hours. These are XP practices. So this is a kind of a litany against fear. I don't know if you read Dune by Frank Herbert, yes? Okay, so you guys might know about this litany against fear. It says that fear is the mind killer. And what the characters in this book are doing is they're saying, I will get this fear through me, and I won't let pass through. I won't let it get inside me, because in this way, if I will let it inside me, it will kill my mind and the way I think. And this is what fear does to us. But fear has always some grounds. So for me, the litany against fear for legacy code is that simple. if you want to have business agility for your company, it's not enough to create the process. It's not enough to have teams that discuss and do retrospectives and all these very nice things about communication and about looking at how people work. You need to invest in what they know, in their knowledge and in their technical knowledge. So this is what I'm doing. I'm finding the unknowns of the team. I make a medium-term learning program with the company. I don't know, 3 to 12 months. I make small-scale experiments. We learn from them. We extend to bigger-scale experiments. We learn again. So we adapt always. And then we start doing a small change requirements in production. And we learn from this again. And this smooth way gives confidence to the teams. So if you want to do this, what's next for you? I would recommend you to read this book, Working Effectively with Legacy Code by Michael Feathers. If you have problems with legacy code, find a good trainer to help the team and to create this kind of program, to build the trust and the confidence. And learn from each experience, because each code is different, and each one of us has different systems. So they are so difficult to put into a generic thought. So thank you. That was my talk.